technically we didn't do it, but you should have all the knowledge you need.
Do you add them together and divide by 2?
Yep. What
Okay.
do you get?
You get 1,6.
1, 6. And that's it. 1, 6. And so end point, and so that's the midpoint, and that's the center of this circle. So you're on the diameter. Okay, how about this?
So 2 comma minus 2 is the midpoint, right?
Yes.
Okay. So would you do 2 minus 2 take away 8 minus 5?
So I think what I might do is coordinates of Q. Let's just call Q xy.
Okay.
So what equation can you construct in terms of x?
Would it be x equals?
It doesn't have to be x equals right away. So like, how would you find the midpoint if it was in terms of x?
It'd be x1 minus x2.
So for this one, you added the two together and then halved it.
So would you multiply and then double it?
So don't think ahead. Just make an equation and worry about solving it later. So for this one, it was like minus 3 plus 5 over 2. The other one was 8 plus 4 over 2. So do that with this one. And it's okay if it's in terms of x and y.
So it'd be x, bracket x, plus 8 divided by 2.
Yeah. And what should the answer be? Or what is the midpoint for x?
2.
And so that's an equation you can make, and you can worry about now the thing you said, multiplying by 2 and all that.
Okay. So we multiply both sides by 2.
Yep.
Which gives you x plus 8 equals 4.
Mm-hmm.
And then you minus 8 on both sides.
Mm-hmm.
Which gives you x equals minus 4.
I think so. Yep. Okay, how about y?
Says y1.
Don't know. Let's see. So 2, 1. Q. Oh, sorry. Minus 4, 1, wasn't it? Yeah, minus 4, 1. Minus 4, 1. And yes, minus 4, 1. Great.
Yeah.
And so just make an equation first and then solve it.
Yeah.
Okay. Unless you have any questions, I'll move on.
Yeah.
Let's try this one.
So is the answer 10, 1?
Sounds good to me. I got 10 as well. Yeah. That one is similar. That's okay. Okay, so we saw perpendicular bisector. We just did one question. Let's see. How about this?
So when it says perpendicular, does that mean it crosses through AB?
Nope. Let's see, the line segment AB. Minus, so it looks like it's going to see something like that. So I'll do my best here. That's my circle.
Okay.
That's B. That's 5, 2. That one is minus 1, 4.
Yep.
We have a diameter. Do you remember what a perpendicular bisector is? Remember what bisect means?
Does that mean it like goes to the midpoint?
Yeah, bisect means like it cuts it in half.
Okay.
So that's your perpendicular bisector, or thereabouts.
Okay. So would you find the midpoint first?
Yep.
Okay. So the midpoint's 2, 3.
Okay. What's next? We want the equation of the line L.
So is it y equals fx plus c? We need to use that.
Yep.
And then do we need to work out the gradient first?
Yep.
So could we just use y2 minus y1 over x2 minus x1 equals m?
Yep.
So when we work out this gradient, is it for the line L?
Well, this is the gradient between A and B.
So, okay.
Because we only have one X and Y for L.
Yeah. So it'd be 2 minus 4 over 5 minus 1, which is minus 1 over 3.
Okay.
And then do we substitute minus 1 over 3?
That would be if it was parallel. This is perpendicular.
So it would be 3 over 1.
Well done. And you can make that simpler.
Oh, just 3.
Yeah.
So it'd be. So then we'd sub in y and x.
Yep.
So from the midpoint.
Yep. Because L goes through only the midpoint.
Yeah. So it's 3 equals 3 brackets 2 close brackets plus c. And then you work out what 3 times 2 is, which is 6. So 3 equals 6 plus c, then we minus 6 on both sides, which is minus 3 equals c.
Mm-hmm.
And then you write it out. So it'd be, would it just be y equals, and then would you put in 3?
Mm-hmm.
X. And then plus 6. Minus 3, sorry.
Yep. Do I have the answer for that one? Y equals 3x minus 3. Wonderful. Let's see. Yep. The perpendicular bisector is the line that goes through the midpoint, cuts it in half. Find the midpoint. Find the gradient, the parallel gradient. Use that to get the perpendicular gradient, and then sub them all in.
Yeah.
So you did very well on that. So I'm because we just did a little bit of it last time, and so I won't spend any time on that. I'll just move on.
Yeah.
This one. How do you find the length of a diagonal line? Does this look familiar?
Yeah. So the bottom one's A, the one on the right's B, and the top one's C.
Yep. And in
is it Pythagoras' theorem?
Yep. What is it?
Is it A squared plus B squared equals C squared?
Yep. A squared plus B squared equals C squared. In terms of coordinates, the way you get the length of A is you do x2 take away x1. The way you get the length of B is you do y2 take away y1. But
Okay.
you kind of know yourself. If it starts at 2, it goes to 5, it's 3 across. You can do 5 take away 2 if you're not sure, for example. But that's all that's about. And it ends up being quite a fancy form. So, this is gradient. The length ends up being quite a fancy formula. A is like, what is A? x2 take away x1. So that's squared. And then it's y2 take away y1. That's squared. And so the length would be the square root. And so it ends up looking quite fancy, but it's just a triangle.
Yeah.
Bunch of stuff. Find the equation. These are mixed questions, I believe. I was looking at it. Here we go. Yep, that's it. Okay, how about this?
So would it be given as a coordinate?
Nope. So you have the point 2, 3. It's a bit across, it's a bit up. You have another point 5, 7. And they literally just want the distance between the two could be represented as the length of a line segment between the two.
So how would you work out the distance then?
How would you work out it? You would imagine that you are Mr. Pythagoras.
Okay.
From way back in the day. And you would make yourself a little triangle.
So it'd be 3 minus 2 on the bottom.
Nope. It goes from 2 across to 5 across.
So it'd be 5 minus 2.
Yep.
Which gives you 3.
Mm-hmm.
And then it'd be 7 minus 3.
Yep.
Which is 4.
Yep.
And then are you just supposed to add them together?
Why is it that you're so good with the Pythagoras? It's just Pythagoras.
Oh. So it's 3 squared plus 4 squared.
Yes.
So it'd be 9 plus 16.
Yep.
Which is 23, I think.
25.
25. Yeah. So C is 25.
It's way too big. C squared is 25.
So any square root is 5.
Yes. That's it. And then when you square root it, you get 5. So it's a length of 5 units, whatever it might be.
Okay.
There we go. So that's what it looks like. And it's 5. Yep. So don't let the coordinates throw you.
Yeah.
Let me see that. No. Suppose. We better do it. Let's just try F, very last one.
Okay. So when it comes to taking away the numbers, does it always take away? Like always?
Yep.
So it'd be 5 minus minus 2?
Yep.
Okay. So I got 7 squared minus 8 squared.
Yep.
Which is 49 and 64.
Mm-hmm.
Which is 113. And then you square root 113, which gives you 10.63.
That's alright, yeah. Like 10.6. Yeah, great.
Yeah.
Okay. I'll get there. This looks good. Okay, how about this?
Okay. So the hypotenuse is 65. Square root of 65.
Yep.
Okay. Okay. So would you need a formula for this?
Yeah, you could use the formula. You could also just do what we just did,
Okay.
but use x instead of a number.
Okay. So it's x minus minus 1.
Yep.
Which is 2x.
Which is x plus 1.
Okay. And the other one is 9 minus 13, which is minus 4.
Mm-hmm.
And then square them and add them.
Yep.
So it'd be x squared, add 1, add 16.
So let's add 16. X plus 1 squared. What does squared mean?
When it's outside of the bracket.
Yeah, just in general. What is squared?
The number multiplied by itself.
Yep. So it's x plus 1 times x plus 1.
Oh yeah, it's 2, yeah. And then you multiply both brackets.
Mm-hmm.
So it'd be x squared plus 1 plus x plus 1.
X squared plus...
1.
Okay, go on. You said lots of stuff.
Oh, wait. No, it's x squared plus 1 plus x plus x.
Yep.
Which is x squared plus... Can you add x and x and make 2x?
Yes.
Yeah.
Yes. So you... Very common thing, people forget the 2 in the middle, which is the 2x's.
Yeah.
X squared plus 2x...
Plus 1.
Plus 1 plus 16.
And then would that just be x squared plus 2x plus 17?
Yep.
And then could you solve that as a quadratic?
What is it equal to?
Wait, what?
So if you're going to solve it, it has to be an equation.
So that's to equal to 0.
Doesn't have to equal to 0. It can equal to anything. What is this thing we just found? What is this we were doing?
We're working out what x is.
So we did... so it's similar to this thing, yeah?
Yeah.
And that gives you the hypotenuse.
Yeah.
Okay. What is the hypotenuse?
Square root of 65. So we're working out a.
Okay. So what will this be equal to?
65.
Correct.
Square root of 65.
It is the square root of 65 squared, because it's like a squared plus b squared is equal to c squared. What is the square root of 65 squared?
Is that just 65?
Yep.
So would it be written out as x squared plus 2x plus 17 equals 65?
Yep. And now we go about solving it.
And then do we minus 65 on both sides?
Correct.
So it'd be x squared plus 2x minus 48.
Mm-hmm.
And then can we put it into the calculator? Equals 0.
Yep.
Okay. Okay. So the first answer could be 6. And the second answer could be... Wait. Yeah, the second answer can be minus 8.
Okay. Yeah, that's possible. X can be positive or negative, just like that one. Grand. So, yeah, you just do it as though you were doing it. So, and that ends up constructing an equation for you. We know that when you do the difference of those two, square it, difference of those two, square it, and add them together, you get c squared. And so you can make it equal to c squared. These kind of working in reverse questions are where it's at. These questions, just finding it, they're going to be okay. The working in reverse, solving equation ones are the ones you have to practice.
Yeah.
Okay, unless you have any questions, I'm moving on.
Nope.
Okay. Okay. The point P. Is that maybe? Let's see. Just want to see this one for a second. Pass through the point through 10. Ooh, there's a lot of stuff going on there. I just wonder, question D. Find the shortest distance between L1 and L2. How do we do that? What's the perpendicular distance between them? I want to graph this. So if I was to graph this, I'll make it bigger in a second. So y equals 2 x plus 4, and then the other one would be y equals it's 2, oh that's weird, 2x plus, sorry, minus 3, I think. I'm just dividing everything by 3 and bringing y over.
Yeah.
Okay, so they're parallel, view, calc screen, normal. We have to find the perpendicular distance. Okay, so how can we find the perpendicular distance between these two lines? Maybe we have to get like a perpendicular bisector. And it goes.
Could you make a line going through the origin, but from top left to the bottom right?
Through the origin, yeah. I'm just going to pick a point that I know.
Okay.
So I know, oh, is that 1.5? Do I know that for certain? This point here is definitely 1, 2. That's definitely minus 3. Is it perpendicular though? How am I supposed to... what would be the perpendicular gradient?
The gradient, the perpendicular gradient.
Yeah. For L1.
Would it be y equals minus 1 over 2?
M2 equals minus 1 over 2.
Okay.
Yes, so that one is y equals minus a half x plus c. And they wanted it goes through the point 3, 10. So when x is 3, y is 10. When x is 3, y is 10. So half of 3 is 1.5. So c is 11.5. So that is y equals minus a half x plus 11.5. I think that would work. Then we'd have to find out where those two cross over. Where does that cross over with this one? And then you could do that. Okay, so what is the point of intersection between L2 and L3, the one we just found?
So would we need to make L2 y equals?
No. This one is y equals. So you could put this one into that one.
Oh yeah, you can, can't you? So it'd be 6x minus 3, open brackets, minus a half x plus 11.5, close brackets, minus 9 equals 0.
Half x plus 11.5, was it?
Yeah, minus 9
Close bracket, minus 9
equals 0.
equals 0. Shift solve. I get 5.8. So x is 5.8. And so what is y?
So now can you substitute 5.8 into y equals minus a half x plus 11.5?
Yep, well done.
So minus a half times I got 43 over 5.
43 over 5, yeah, that's 8.6. That's it. So that's the point of intersection. And so how do we use those points that point 5.8, 8.6 to get the perpendicular distance between these lines.
Okay. So we'd use Pythagoras' theorem.
Yeah, with which two coordinates?
5.8 and 8.6.
That's one pair of coordinates.
Oh yeah. Would it be 5.8, 8.6, and 3 and 10?
Very good. Yeah.
Okay. Okay. So would you do 3? Oh no, would it be 3 minus 5.8?
Yep.
Okay. Minus. And then close brackets squared.
Mm-hmm.
And then open brackets 10 minus 8.6.
Yeah, and you don't have to do it the way I'm doing it. There's a plus in between the two brackets because you'd
Okay.
add the two together. You can't. It is like less mentally taxing to kind of write it down first.
Which is 3.1.
Okay, and then you. So you did okay. Let's say 3.13, three significant
Yeah.
figures. Great. So the reason why I did it that kind of quick way was because I wasn't sure how to go about this question.
Yeah.
And it turns out it wasn't too bad. So you basically find the equation of a perpendicular line. You find the second point, like the point that goes through the point of intersection on the other line, and then find the distance between those two coordinates. So that's how you find the distance between two parallel lines. Okay.
Okay.
And I didn't realize they'd be parallel because that wasn't obvious. Okay, so this is an exam question. Let's give this a go.
Okay.
It looks a bit different. Aha, okay.
So we know is the gradient 3x minus 3x.
Minus 3, yeah.
Minus 2. So m2 is 1 over 3.
Yep.
Okay.
So what do we do with this stuff?
So we know the m1 and n2, but we don't know. We know what c is, but we don't have any coordinates. We only know the square root of 34.
I'm trying to. I'm pressing the wrong thing. Yes, and so this is what it looks like. We need the distance from that line to the origin. Oh no, sorry. We need the distance is root 34. We need two positions of P. Lies on the line with this equation from the origin. So I think, so maybe it's not perpendicular. I think maybe it can't be or something, is it? A point P lies on the line. The point P is a distance of root 34 from the origin. I think it would have to be like a little that way and a little that way or something for there to be 2 points. I think there's only 1 point that's exactly the shortest.
Yeah.
So how could we do that?
So that distance is 34. Square root of 34.
Yeah.
So when you write P is x comma y, what does that mean?
So we're trying to find the point P.
Okay.
And so
On the line, right?
Yeah.
Okay.
So I'm just kind of...
So would you use... Well, you can't. Actually, so be y. So would you write out as y equals a third x plus c?
No. I think it's not perpendicular. I think if it was perpendicular, there'd only be one line. There'd only be one possible coordinate, and it would be exactly the shortest one.
So would you just use y equals minus 3x plus c?
I think so. So the distance is root 34 from the point P to the origin.
Yeah.
So I'll call it P1 and P2. And so, how can you use that?
Could use it to work out the difference between P1 and P2.
Possibly, I would do Pythagoras with the point P and 0, 0, 0, because it says it's a distance of root 34 between those two.
So are you using 0, 0?
Yeah, because it's the distance from P to the origin. The point P is a distance of root 34 from the origin.
So to use Pythagoras, you need another coordinate. Oh no, you have the you have the hypotenuse, don't you?
Yeah.
So it'd be, is it c squared equals? Wait, is it c square root of c? C squared equals b squared minus a squared.
Just Pythagoras in general. A squared equals b. A squared plus b squared equals c squared. Okay, what is a in terms of what we have?
A is 0, 0.
It's the difference between the x's.
Would it be 0?
Difference between the x's. So for this one, we had to do 3, like 5.8 minus 3, 8.6 minus 10.
Yeah.
So this one.
But you're not taking, you'd have another coordinate to take it away from.
We've got plenty.
Oh, so it'd be x minus 0.
Yeah.
Plus y minus 0 equals brackets 34 close bracket squared, which is just 34.
And these are also squared.
Okay. Okay.
What was I going to say? What is x minus 0?
That's just x.
So that's x squared.
Plus y squared.
Yeah.
Equals 34.
So we know x squared plus y squared gives us 34. We also know that y equals 4 minus 3x.
So do we write it out as 2 brackets?
And what are the two brackets?
4 minus 3x, 4 minus 3x.
Well done. So that is y, and so we can put that in there.
Okay.
And yeah, go on, write it as two brackets, expand it. What do you get?
So it'll be 4 minus 3x and 4 minus 3x.
Mm-hmm.
Okay. So I got 16 minus 12x minus 12x minus 9x squared.
Mm-hmm.
And then,
Hang on, what's a minus times a minus?
oh yeah, they're just 9 plus 9x squared.
Mm-hmm.
And then you simplify minus 12x and minus 12x, which gives you minus 24x.
Mm-hmm.
So it'd be 16. So it'd be 9x squared minus 24x plus 16.
Yep.
Which equals 34.
Yep. And don't forget we had 1x squared at the start.
Yeah. So can you simplify x squared and 9x squared?
Yep.
Which gives you 10x squared.
Mm-hmm.
So 10x squared minus 24x plus 16 equals square root of 34. Or just 34, sorry.
Yeah, because it was squared.
Yeah, and then you minus 34 on both sides,
Well done.
which gives you minus 18. 10x squared minus 24x minus 18 equals 0. And then you can put that into the calculator.
Yeah.
So it'll be 10x squared minus 24 minus 18. So first answer can be 3, and the second one can be minus 3 over 5.
Okay, so it turns out it was kind of like up there or something.
Yep.
Is that full marks? Y coordinate.
Oh yeah. They want like the full coordinate.
I said positions. Yeah,
Okay.
we need to know the y. It's probably a negative y for the positive x.
So, oh, so we just, okay. So we do 4 minus 3, then we substitute x1 in.
Yeah.
Which gives you 4 minus 9, which is minus 3. Wait, no, minus 5.
Mm-hmm.
So the first answer is 3, comma, minus 5.
Well done.
The second one would be 4 minus 3 brackets minus 3 over 5. And let's put that to the calculator. which is 9 over 5.
Great.
And then 4 minus 9 over 5, so 4. Which gives you... Wait, no. Would it be 4 plus 9 over 5?
Correct. Minus times minus makes plus.
So it's 29 over 5. So the last one would be minus 3 over 5, comma 29 over 5.
Well done. So I'll never say I didn't do the difficult questions with you. It's a problem I used to have. I used to just do the normal ones. But exam questions always have these weird,
Yeah.
reverse type. It is just, believe it or not, it is just Pythagoras, and it's equal to root 34 squared.
Yeah.
And then you solve it. I just wrote it in terms of x and y, and then make an equation, solve an equation. But it's just long and brutal.
Yeah.
But you got it. Any questions about that?
Nope.
Okay. Yes, we could. There's one type. There's one type I really want to get to. What's the area of this triangle?
Okay. Wouldn't it just be 6 times 4 divided by 2?
Yeah. Well, hang on. How'd you get 6?
Isn't the triangle base times height divided by 2?
Yeah. What's the base?
Oh, it's 3.
Yeah.
Which is 3 times 4 is 12, so it'd be 6.
So that's 6, let's just say centimeters squared. And yes. And so you can do something like that to get the area. Alright, let's see. But the area is never very complicated with these because all the other stuff is complicated. Okay, how about this?
Could you put it in as a simultaneous equation?
Yeah, you could actually, you're right.
So it'd be 4x minus 1 equals 0. And then so x is minus 3 over 2. And y is minus 6.
Okay, how would you do part B?
Wait, I've got a question. You know when you put it into the calculator, for minus 21, do you put that where the 0 is, or do you keep it as 0?
That should be where the 0 is. That's what I was checking.
Okay.
So what did you put in your second line in your calculator? 2, 3, and...
I put 2x and then 3y and then minus 21.
And so if you brought 21 over, what would it be? Or minus 21 over, what would it be?
Plus 21.
Yeah, so that should be plus 21. So it's 3 over 2 and 6. So A, I'll say 1.5. 1.5 and 6. And B.
Okay. So now should we substitute 1.5 and 6 into 4x minus y equals 0?
If you did, you should get 0 if it's correct, which it is. They asked us to find the area of a triangle. Might help if we sketch it.
Yeah.
So for the first one, L1 might look a bit like that.
Yep.
L2. Let me think this through. L2 might look a bit like that. We found where they crossed over. That's A.
Yep.
O is the origin. And B is the point where L2 meets the x-axis. So that's B.
Okay.
So we have to find the area of that triangle.
Okay.
How do we go about that?
So we know the height is 6.
Yep.
We just need to find the base.
Well done.
So is the base 3?
That's if it's isosceles. Might not be.
Okay.
Oh
yeah, that is true.
It's
okay.
where L2 crosses the x-axis.
Yeah.
What do you know about where it crosses the x-axis? The coordinates at a point where a line crosses the x-axis.
But the y coordinate's always 0.
Correct.
So we written out as x comma 0
Yep.
for now.
Yep. So on the line L2, y is 0. What is x?
So if y is 0, can we put that into an equation?
Which one?
4x minus y equals 0.
That will give you the origin. This B isn't on L1, it's on L2.
So do you use y equals mx plus c?
No, you use the equation L2.
Oh, but they both equal to 0.
Makes a difference. A minute ago you said 2x plus 3y equals 21. If that helps.
Okay. So it'd be 2x plus 3 brackets 0 equals 21. So it'd be 2x plus 0 equals 21. So it's 2x equals 21. And then we divide by 2 on both sides. So 21 divided by 2. Whoops. Which is 10.5. So x is 10.5.
Yep.
So then we do 10.5 times 6 divided by 2.
Yep.
Which is 63 over 2. Or 31.5.
31.5?
5.
That's it. So 31.5 square units.
Centimeters cubed. Squared.
Might be centimeters, but we don't know.
Okay.
Yeah, 63 over 2 they wrote it as, same thing. Great. Yeah, it's a half times base times height, and the height was 6. We just had to find the base we know that y is 0 on the line L2. And so on the equation of the line L2, when y is 0, x is 10.5, and so the base is 10.5.
Yeah.
Okay. Let me just see. I saw this thing. Work out the area of the triangle RST. RST. I'm not crazy about that question. These are perpendicular. That's not too bad. How would you do that?
Okay. Okay. So it wants the red line that you've drawn. Does it
No.
want the area? Wait.
Area. I skipped all the way down to E.
Okay. So we use Pythagoras' theorem first
For what?
to work out the lengths of RS and RS.
Yeah. And so Pythagoras for RS. That would be 4 squared is 16. So that would be root 20, I think. And what's next?
Now, we don't know what both TS and TR are. The length.
Well, the coordinates of T. Coordinates of T. Oh, I don't know the answer. So I'm not too pushed about that one. Let me just take a quick look. TR L2 is perpendicular, goes through R. Coordinates of T. I don't know. Let's just say it's 5 or something.
Yeah.
How would you find the area?
Base times height divided by 2. So it'd be square root of 20 times 2 times 5 divided by 2.
Yeah.
Which is 5 root 5 or 11.2.
Okay, yeah. 5 root 5 and it's like something root 5. Those questions, the difficult bit is never the finding the area at the end. They almost always look like this one here that we did. They're usually very simple, where one of the points is on the origin, one point is either on the x-axis or the y-axis, and it's always just a half base height.
Yeah.
Great. So area, it's a half times base times height, but it might be, in terms of coordinates, so you just have to figure out the base and height. The length of a line is Pythagoras, but it looks weird because it's got the formula, but don't let that throw you. And so that stuff, x a half a tick, what do you give yourself?
Probably between a tick and a half.
Okay. Oh, I swear we're nearly finished this thing. It's only a tiny bit left. How was that for you, Adam?
That was great.
Hey, it's good to hear. And so finish this one and then next chapter next time?
Yep.
Okay, any questions for me in general?
Nope.
Alright, well, happy Guy Fawkes night, and I'll talk to you next time.
Bonfire night. You too.
I don't know what it's called. I didn't grow up in this country.
Okay, bye.
Take care. Goodbye.
You too, bye.